Hi everybody, this is Eduardo Suarez. Today we're going to look at a different topic in iRVision 2D, that is iRVision inspection. iRVision inspection is a function that takes an image of a part that we're going to call the target to be inspected. It analyzes a part looking for different features and then evaluates if the features meet the specific conditions. And based on that, determines if the target passes or fails the inspection. So what we're doing up to now in the previous videos was using iRVision to compensate robot motion. What we're going to do in this video is something different. iRVision inspection doesn't output any offset data or measurement values. Instead, it gives a pass or fail for the inspection result. The result of the evaluation is going to be stored on a register, and the output of the result can either be 0 if the result is evaluation fails, 1 if the result of the evaluation passes, or 2 if the result of the evaluation couldn't be determined for any specific reasons. Then we're going to use the result of the evaluation stored in the register to create a TP program that can take different actions. So for example, if you're inspecting a part that's coming out of the assembly line, this inspection can be used as a quality control, and you can discard the part if the inspection evaluation fails or couldn't be processed. The inspection tool that I'm going to show you in this video is called AI error proofing. The AI error proofing tool is a learning process. We're going to use images that we're going to classify into different categories, either pass or fail. And when the AI error proofing tool is executed, it evaluates if the target image fits on any of the two categories. I'm going to show you first the part that we're going to use as a target for inspection. This is a mechanical part that's going to be heat treated on 4 different areas. And the area that's going to be heat treated is a cutout that has some teeth on the outside. The image on the right is after the process of heat treatment. The heat treatment is done by placing the part on an induction coil that heats only a specific area of the part. And after the heat treatment process is done, the area changes to a dark color characteristic of the heat treatment. So the idea of the inspection process is to determine if the heat treatment was done in all of the 4 areas. The process to evaluate if the target passes or fails is a learning process where we're going to teach the inspection tool using different images. We're going to start by creating a new work cell. We're going to open the teach pendant. We're going to select status. We're going to go to version ID. We're going to go to next, and we're going to select order F5. And in here, you're going to see that in addition to the iRVision 2D package, I have installed the iRVision AI error proofing, the S522, and also I have the Vision Support Tools JA73. As usual, we're going to add the camera to the sensor unit, and we're going to connect the camera to the robot controller. We're going to enable the vision simulation, and on the vision properties, we're going to connect the camera to the port 1 on the robot controller. We're going to open iRVision. We're going to select Vision, Vision Setup, and we're going to create a new camera data. We're going to select Edit. On the camera setup, for camera, we're going to select Camera Setup for image files, and we're going to press OK. In this case, instead of using the live camera images, I'm going to use the images from a file. For robot mounted camera, we're going to select No. And for calibration, we're going to select No calibration. Since this is an inspection process, it doesn't output any offset data or measurement values. For that reason, we don't need to use any calibration grid. we're going to select File, and on the Use Image As, we're going to select Grayscale Image, and we're going to select the drive. In our case, we're going to use the USB drive located on the touch pendant. We're going to save, and we're going to end the edit. Now we're going to create a vision process. We're going to select Others and Single View Inspection Vision Process. We're going to give it a name. And we're going to press OK. We're going to go to Edit. You're going to notice now that the layout is different. We're going to have the Parent tool, and as a Child tool, we're going to have the Snap tool and an Evaluation tool. On the Parent tool for camera, we're going to select Camera 1, and for Image Logging Mode, we're going to log any image. We're going to select the Snap tool. We're not going to make any changes over here. And the next thing that we need to do, we need to add the AI error proofing tool. So for that, we're going to go back to the Parent tool and make sure that you select the Parent tool and not any of the Child tools. Otherwise, you're going to add the AI error proofing tool as a child of one of the Child tools. So now we're going to select Add, and on the inspection measurement, we're going to select the tool for AI error proofing, and we're going to press OK. So you're going to notice now that the AI error proofing shows as a child of the Parent tool and always after the Snap tool. You're going to notice that this tool has two classes, class 1 and class 2, because the output is going to be always either pass or fail. So we're going to give it a meaningful name. Class 1, we're going to call it pass, and class 2, we're going to call it fail. Now we need to train the measurement area. We're going to press Set, and we're going to move the control points to select the area that we want to evaluate, and we're going to press OK. And I was going to tell you that we can start doing the learning process. So we're going to go to a new window, and in this window we need to take at least 2 images for the class 1 and 2 images for the class 2. We're going to select images newly snapped. We're going to go to Next, and first we're going to take the image that we have in here. You're going to notice that we are in live mode. So we're going to select Find, and we are going to add this image to the log. Next thing that we need to do, we need to select 3 more images. So for that, we're going to select the USB drive. We're going to go back to the work cell. We're going to select Tools. We're going to select the folder for the work cell. We're going to select Robo 1. And we're going to select the folder for the USB on the touch pendant. Right now I have an image in there, and we're going to get a new image. I'm going to add another image, and I'm going to delete this one. Now we're going to go back to the learning process. We're going to select Find, and we're going to add this image again. And now we have 2 images for class 2 that is fail, and we need 2 more images at least for pass. I'm going to select the good image. That's going to be the one that we're going to consider for pass. We're going to take another snap, and we're going to add this image. And finally, we're going to add 1 more image. We're going to do another find, and we're going to add this image. So now that we have 4 images, we're going to select Next. And something that you have to consider that this is a learning process. So if you keep adding more images, you're gonna improve the quality of the result. So now we need to select if it is an image for class 1 or class 2. We're gonna consider this one as a fail, and this one as a fail, and this one as a pass, and this one as a pass. Now we're gonna go to next, and we can finish. Now we're back on the AI error proofing tool, and we have finished with this process. And now we need to go to the evaluation tool. For the evaluation tool, we're going to select the variable tab. You're going to notice in here that you can select up to 10 variables from variable 1 to variable 10. We're going to select the variable number 1, and this is going to be the AI error proofing one. And from here, we're going to select the two outputs that this tool is going to give us. That can either be class or confidence. For variable 1, we're going to select class, and for variable 2, we're going to select confidence. Now that we have the variables, we can go to the conditions. This is going to be the conditions that we're going to use for evaluating the process. So we're going to check condition 1, and for condition 1, we're going to select variable 1, and we're looking for variable 1 equal to 1, that is going to be pass. So we're looking as a condition that the evaluation passed. And with this, we can save. So now we can start doing a small test. We're going to go to the single view inspection vision process. We're going to do a snap and find. And you can see here that this image passed. And you can see here the result. The number find is going to be 1. And the condition, we're looking for the class. And the value for the class is 1. We can go back now to our folder, and we can select another image, an image that we know that's going to fail. So we want to replace our image. And now we're going to do another snap and find, and the result is fail. And you can see that the class is 2. That means that it failed. If you want to improve the learning process, you can keep adding more images. You select the AI error proofing tool. You take another snap and find, and then you just select in here add found result, and you can select in here this is a pass or fail, and just go to next and finish. We're going to save, and now we can go back to the work cell. On the work cell, we're going to open the teach pendant, and we're going to select the TP program. I have already created the program here. I call it Vision Inspection. One thing that we're going to do, we're going to go to detail, and we're going to remove the group mask since this program doesn't have any motion instruction. We're going to select the program, and you're going to see here that the program is very simple. The first thing that we're going to do, we're going to call the Vision Run Find instruction using the Vision process. The next thing that we're going to do, we're going to call the Vision Get Pass Fail using again the Vision process, and we're going to save the result in the register number 1. So register number 1 is going to be the AI error proving result, and register number 2 is going to be the AI error proving confidence. The next instruction is going to be a call of a carry program, and this carry program is taking 4 arguments. The first argument is going to be the vision process name. The second argument is going to be the first register number for the measurement values. The third argument is going to be the first measurement value. And the fourth argument is going to be the number of measurement values. When we talk about measurement values, we're talking about in here on the evaluation tool of the variables that we have. So this measurement value number 1 is going to be the class, and the measurement value number 2 is going to be the confidence. The next thing is going to be select instruction, and based on the result we can jump to different labels. So label number 10 is going to be if the vision failed, and we can take some action in here. Label number 20 is going to be if the vision passed, and we're going to have two more labels. If the vision result is unknown, that would be when we have value number 2, and then if the select instruction gives us any other number, that's going to be label number 4. So this would be up to you to write in here the code that you need for your program. I'm going to show you first how you create this instruction in here. We're going to do an instruction call. We're going to call a program, and over here we're going to go to collect. We're going to select carried programs and enter, and over here we need to find the carried program. This carried program is under the Vision Support Tools option packet that we have already installed. We're going to select the program, and now we need to add the arguments. We're going to select choice, and we're going to go to insert. We're going to insert string, and we're going to select in here string, and I couldn't find any other way to add the vision inspection process, so we need to type it manually. And now just keep adding more arguments. In this case, it's going to be a constant, and we need two more arguments. And we are done. Now we can run the program. We're going to go in step mode. We're going to run the vision run fine. We're going to get the get pass fail. You can see now that the register number 1 is 0 because we are running the image that failed. So the result is going to be 0. And now we're going to get the confidence on the register number 2. And we got a confidence of 99.4%. We're going to keep running the program. This is going to jump to label number 10. And we're going to end the program. Now we can change the image. We're going to select an image that we know that is going to pass. And we're going to run the program again. Register number 1 is 1. We get the confidence, and we're going to go to label number 20. And we end the program. There are many different ways we can do the evaluation. Now I'm going to show you another alternative. We're going to go back to iRVision, and we're going to create a new vision inspection process. We're going to go to edit. we're going to select the parent tool, we're going to select the camera, and this time we're going to add a GPM locator tool. We're going to go to Teach, we're going to select the area, we're going to go to Train Mask, and we're going to be looking only for this area. We're going to select the Erase, and we're going to be looking only for this area. Now we're going to select the GPM locator tool as a parent tool, and we're going to add a child tool. In this case, we're going to select the AI error proofing. We're going to do exactly the same. We're going to set the measurement area. We're going to press OK. And now we need to do the learning process. I'm going to skip this part in here. I'm going to do that offline to make the video shorter. And we're going to continue after that. The next thing we're going to do, we're going to select again the GPM locator tool, and we're going to add another child tool. This time it's going to be an evaluation tool. And for the evaluation, we're going to select the variable tab. We're going to select the variable number 1, AI error proofing. We're going to select class. As a variable number 2, we're going to select the confidence. We're going to select the condition tab. We're going to check condition 1. We're going to select variable 1. And we're looking for the class to be 1. And we're going to select the condition number 2. And we're going to be looking for the confidence to be greater than 80%. Now we're going to go back to the parent tool for the single view inspection vision process, and we're going to select another tool. This time we're going to go to calculation and logic, and we're going to select the count tool. Notice that the count tool is showing as a sibling to the GPM locator tool, and below that we're going to check the locator tool, and we're going to select the GPM locator tool 1. So we're going to use this count as a tool for the evaluation. So now we're going to select the evaluation tool. We're going to go to variables. For variable 1, we're going to use the count tool 1. And we're going to be looking for the number that passed. And now we're going to go back to the condition tab. And for the condition number 1, we're going to select the variable number 1. And we're going to be looking for the number of pass equal to 1. With this one, we can save and we can test the program again. We're going to open the Teach pendant and we're going to create a new TP program. This time the program is going to look a little different. We're going to have the instruction Vision Run Fine as before. we're going to have the instruction vision get number found instead of the instruction get pass fail, and we're going to save the result on register number 10. In our case, we have only one part to be found, but this program is a little more generic, so we can consider that the number of parts to be found could be greater than 1. Then we're going to create an index on register number 11, and we're going to run a for loop to loop through all the parts that we found. In the next line, we're going to call a carry program, and this carry program is going to give us the variables in the evaluation tools. They are children from the locator tools. In our case, we have only one locator tool, but we could have a more complex vision inspection process that requires more locator tools. So the arguments for this carry program are going to look like this. Argument number 1 is going to be the vision process name. Argument number 2 is going to be the found part index that we put already on register number 11. Argument number 3 is going to be the register number for pass fail result. In our case, it's going to be register number 12. Argument number 4 is going to be the register number for the model ID. We're going to put it on register number 13. If we look at the locator tools, each one of the locator tools that we add in our vision inspection process is going to have a model ID. And what we need to do, we need to select a different model ID for each one of the locator tools that we keep adding as a child from the vision inspection process. We're going to continue with argument number 5. That's going to be the first register number for the measurement values. And then we're going to have argument number 6 and 7 that are optionals. And I haven't included here as an argument for the carry program. So if we go back to the program, the next instruction after the for loop is going to be the same call that we did before for the carry program, where we're going to have the variables for the evaluation tool number 1. So to clarify, the carry program that we ran on line number 5 is only for the variables that we have on the evaluation tools that are child from a locator tool. And line number 8 is going to be the carry program that we use for the evaluation tool that we have at the end as a child of the vision inspection process. We are ready to run the program. Right now, we're going to run the program with an image that's going to fail. So we're going to run again on step mode. We run the vision find. We get the number found. In our case, the number of parts found is going to be 1. We're going to go to the for loop, and this loop is going to run only one time. We run the carry program, and we got the result on the register number 11, 12, 13, and 14. So this is our index for the for loop, and this is the result. The result failed. The model index is going to be 1. It's the one coming from the locator tool. And the measurement value, we're going to have 2. We're going to have the class, and we're going to have the confidence. And these 2 are the variables that are coming from the evaluation tool. We're going to keep running the program. We're going to run the next carry program. And in this case, the result is fail. That's why we have 0 on register number 20. We got the vision fail. We go to label number 10, and we end the program. Now we're going to use a part that we know that's going to pass. We can take a snap and find, and we can run the program again. We're going to get the number found. we're going to run the for loop. This time, register number 12 is a passed, it's going to be 1, and the measurement value on register number 14 is going to be the class, is 1, and this is the confidence value. We're going to keep running the program. We have in here on register number 20 the result, that's going to be 1, and if we keep running on the select instruction, we're going to go to label number 20, that is vision passed, and we end the program. In conclusion, the vision inspection process uses an evaluation tool where we can put all the conditions that we want to evaluate for the inspection. The result is going to be either pass, fail, or undetermined. That means that we can only evaluate for binary conditions such as good or bad, pass or fail, part A or part B, etc. In particular, in this video, I show you the AI error proofing inspection tool. This tool uses a learning model, and the main advantages of this model is that it's very easy to use and doesn't require any vision process experience for the programmer that configures the tool. Something that you have to keep in mind is that as you keep adding more images for the learning model, it might take more time for the vision processing, so it might compromise your cycle time. One way to understand the simplicity and advantages of this tool is to compare this vision process with any other vision inspection tool that is available on the iRVision package. And with this, I'm going to conclude the presentation for this video, and thank you for watching.